Current agent frameworks are stuck between two extremes. You've got reactive prompting like React, where the model implicitly controls the flow and state through open-ended loops. This works for simple tasks, but fails on long-horizon reasoning, leading to context rot and uncontrollable behavior. Or you have orchestration frameworks like LangGraph and DSPy. They add structure, but they tightly couple your workflow logic to Python code, making agents hard to version control, share, and modify without a programming background. AgentSPEX solves this with a declarative specification language. You define agent workflows in YAML, keeping control flow, state management, and prompts separate from execution code. This makes workflows easy to diff, version, and share, while allowing domain experts to author agents without writing Python. Technically, AgentSPEX introduces a rich set of primitives. You have task operations that instantiate fresh conversations, and step operations that maintain persistent multi-turn history, giving you granular control over context injection. The language supports typed steps, conditional branching with if and switch, loops with while and for each, and parallel execution with gather. State management is explicit. Workflows maintain named context variables. Steps reference these via mustache templates and save outputs using save as. This allows precise control over what context each step receives, mitigating context degradation. Unlike React, which carries full history, AgentSPEX can restrict context visibility per step, improving cost and performance. You can also compose workflows using a unified call abstraction, treating skills and subagents as reusable modules. The AgentSPEX harness is the execution engine. The interpreter validates the workflow structure, resolves configuration, expands templates, and dispatches operations with hierarchical step identifiers for checkpointing. The executor manages the multi-turn interaction loop, terminating on no tool call responses or configured limits. Workflows run in a Docker-based sandbox with tool access via the Model Context Protocol. It includes a built-in observability dashboard for real-time monitoring. For durability, it supports checkpointing after every step, recording context, metrics, and sandbox state. This allows workflows to resume from any point. It also features selective trace replay. You can load a prior execution trace and resume live execution from a specific step, isolating the impact of prompt changes without rerunning upstream nodes. This explicit structure unlocks formal verification. Because control flow is declarative, you can define pre- and post-conditions for steps and verify execution trajectories using theorem provers like Lean or Isabelle. We also provide a bidirectional visual editor. You can drag and drop nodes to modify the graph, and changes sync instantly to the YAML source or vice versa. Evaluation results are strong. AgentSPEX beats Coty and React baselines on 7 benchmarks, including SWE Bench Verified, AIME 2025, and scientific reasoning tasks. On a late bench, it improves over Coty by 6.5%, and on Chem Bench by 5.5%. It achieves a perfect score on AIME, and outperforms specialized agents on SWE Bench. A user study confirmed developers find AgentSPEX significantly more readable and accessible than Python-based alternatives. AgentSPEX makes agent development reproducible, modular, and verifiable. Check out the code and demos on GitHub.